For millennia, humanity has gazed upon the night sky, a tapestry of shimmering stars and swirling nebulae, believing we understood its grand design. We charted the constellations, named the planets, and marveled at the predictable ballet of celestial bodies. But what if, hidden within this cosmic ballet, there existed an unseen terror, a silent, solitary hunter, adrift in the endless dark? Imagine a force so profound, so utterly inescapable, that not even light itself can break free from its grasp. A gravitational abyss, a tear in the very fabric of space-time. We speak, of course, of black holes, but not the supermassive behemoths that anchor galaxies, nor the binary dancers locked in a deadly embrace. No, we speak of something far more elusive, far more mysterious. They are the universe's true wanderers, the cosmic ghosts. Untethered, unburdened, and utterly alone, they are rogue black holes, stellar remnants, flung from their violent birthplaces, now traversing the vast interstellar ocean. But what are these enigmatic entities? How did they come to be? And what potential dangers, or indeed profound secrets, do they hold for our understanding of the cosmos? Join us as we embark on a journey into the dark heart of the Milky Way, hunting for the unseen, the rogue black holes. To understand a rogue black hole, we must first understand its violent genesis. These aren't the primordial black holes, theorized to have formed in the universe's infancy, perhaps even tunneling through our very planet. No, the rogue black holes we seek are born from the fiery death of colossal stars. Imagine a star, many times the mass of our own sun, burning through its nuclear fuel at an astonishing rate. For millions of years, the outward pressure from its fusion core battles against the relentless inward pull of its own gravity. But eventually, the fuel runs out. The delicate balance is shattered. With nothing left to counteract gravity, the star's core collapses in mere milliseconds. The implosion is so catastrophic, so incredibly energetic, that it rebounds, sending a colossal shockwave tearing through the star's outer layers. This is the supernova, an explosion so bright it can briefly outshine an entire galaxy. It is a cosmic farewell, a spectacular display of destruction that seeds the universe with the heavy elements necessary for planets, and indeed, for life itself. But within the heart of this cataclysm, something even more profound occurs. If the dying star was sufficiently massive, typically more than 20 times the mass of our Sun, its core collapses beyond the point of no return, forming a stellar mass black hole. And here lies the secret to its rogue nature, the supernova itself. The explosion is rarely perfectly symmetrical. The immense forces unleashed can deliver an uneven kick to the newborn black hole, propelling it away from its stellar nursery at incredible speeds, speeds that can reach tens, even hundreds of kilometers per second. Once ejected, these cosmic outcasts embark on an endless, solitary journey through the interstellar void. They are no longer bound by the gravitational embrace of their home galaxy, free to wander the vast, cosmic ocean. Their paths are determined by the initial kick and the subtle gravitational influences of the galaxy's overall mass distribution. They are the ultimate nomads, silent and unseen, traversing the cosmic landscape for billions of years, perhaps even crossing paths with other galaxies during galactic collisions, though their individual trajectories are rarely affected by such grand cosmic dances. Finding a rogue black hole is akin to searching for a ghost in a cosmic haystack. They are, by their very nature, invisible. They emit no light, no radiation, no telltale glow. Their gravitational pull is immense, but in the vast emptiness of interstellar space, their influence is often too subtle to detect directly. So how do we hunt for something that is, by its very definition, unseen? The answer lies in one of the most profound predictions of Albert Einstein's theory of general relativity, gravitational lensing. Einstein postulated that massive objects warp the fabric of space-time around them, and this warping, this cosmic indentation, can bend the path of light rays that pass nearby. It's as if the universe itself becomes a colossal, imperfect lens. A century ago, in 1919, the British astronomer Arthur Stanley Eddington famously proved this during a total solar eclipse, observing how the sun's gravity subtly shifted the apparent positions of distant stars. His groundbreaking work laid the foundation for how we now seek these dark wanderers. For rogue black holes, this phenomenon manifests as a fleeting cosmic event known as gravitational microlensing. As a rogue black hole drifts across our line of sight to a more distant background star, its immense gravity acts as a magnifying glass. The star's light is temporarily amplified, causing it to brighten significantly. Crucially, the black hole's gravity also subtly deflects the star's light, causing a minuscule but measurable shift in the star's apparent position in the sky, a technique known as astrometry. These telltale flickers and shifts are the only clues these cosmic phantoms leave behind. For over a decade, dedicated astronomical surveys, such as the Optical Gravitational Lensing Experiment, or OGL, and the Microlensing Observations in Astrophysics, MOA, have been tirelessly scanning the skies for these elusive events. And in 2011, they spotted something extraordinary. A distant star, some 20,000 light-years away, suddenly brightened. It was a tantalizing clue, but it took years of meticulous follow-up observations with the Hubble Space Telescope, led by astronomer Kailash Sahu, to confirm the true nature of the lensing object. The key was not just the brightening, but the precise measurement of the star's astrometric shift, a deflection so tiny it was 1,000 times smaller than what Eddington measured for the Sun. The verdict was in. The unseen object was indeed a black hole, weighing in at approximately 7.1 times the mass of our Sun, hurtling through space at around 45 kilometers per second. This was the first unambiguous, observationally confirmed rogue black hole, a monumental discovery that validated decades of theoretical predictions and opened a new window into the hidden population of our galaxy. The very idea of a rogue black hole, a silent, invisible behemoth hurtling through the cosmos, can conjure images of cosmic catastrophe. What if one were to enter our solar system? Could it devour our planets, or even our Sun? While the thought is certainly unsettling, the reality is far less dramatic. The vastness of space is almost incomprehensible. The chances of a rogue black hole directly colliding with Earth, or even significantly disrupting our solar system, are astronomically small. Our cosmic neighborhood is simply too sparse. However, their existence does pose intriguing questions about the potential for life in other star systems and the long-term stability of galaxies. Beyond the speculative dangers, rogue black holes offer a tantalizing opportunity to unravel some of the universe's deepest mysteries. For instance, could these unseen wanderers contribute to the enigmatic phenomenon of dark matter, Dark matter, an invisible substance that makes up a significant portion of the universe's mass, remains one of cosmology's greatest puzzles. While rogue black holes alone cannot account for all of it, their sheer numbers, potentially millions of them lurking in our own Milky Way, suggest they could be a significant, previously uncounted component of the universe's unseen mass. Studying their distribution and properties could provide crucial clues to the nature of dark matter and the evolution of galaxies. The recent confirmation of a rogue black hole is just the beginning. The next decade promises a revolution in our ability to detect these elusive objects. The European Space Agency's Gaia telescope, already meticulously mapping the positions of billions of stars, is expected to release lensing data in 2025 that could reveal dozens more stellar mass singletons bolting around our galaxy. Following closely behind, the Vera C. Rubin Observatory in Chile, scheduled to begin its 10-year survey next year, and NASA's Nancy Grace Roman Space Telescope, set to launch in 2027, will possess unprecedented wide fields of view. These powerful instruments will capture panoramic vistas of the night sky, allowing astronomers to identify countless more microlensing events and, in turn, pinpoint a veritable harvest of rogue black holes. From the violent birth of a dying star to a solitary journey through the cosmic abyss, rogue black holes are a testament to the universe's boundless capacity for wonder and mystery. They are the silent witnesses to cosmic history, the unseen architects of gravitational dance, and perhaps the missing pieces in our grand cosmic puzzle. Their discovery reminds us that even in the seemingly empty stretches of space, profound secrets lie hidden, waiting to be unveiled by human ingenuity and curiosity. The universe is a symphony of the seen and the unseen, the known and the unknown. And as we continue to listen, to observe, and to question, we draw ever closer to understanding the true nature of this magnificent, bewildering cosmos. What other wonders, what other cosmic ghosts still await us in the endless night?